Order of the chemical reactions, 0 and first order. The rate of chemical reaction is the measure of how quickly the reactants change into the product per unit time. So we can measure the rate of chemical reaction by using rate law, which is a mathematical expression that shows how the rate reaction relates to the concentration of the reactants. Rate law equal to the constant times the concentration of the reactants raised to the power, which is reaction order. You have to remember is that we have to determine these experimentally. The time now to talk about the order of the reaction.
The order of reaction refers to the power dependence of the rate on the concentration of each reactant. There are 3 types of order: 0, first and second, and today I will visit 0 and first at their homes.
Hi, I'm the zero order reaction, which occurs when no concentration term affects the rate of reaction or the rate of reaction remains the same throughout the reaction. So we will take this example of the breakdown of ammonia into hydrogen and nitrogen gas. Looking to the data, we realized that the rate on 3 experiments is going to be identical even when the concentration is varied. So it is the zero order. So if we compensation on the rate law, we will have the rate equal to the rate reaction constant, since it is raised to power 0, which is the order, and equal to 1. Then, the graph shows it's going to proceed a straight line. So if we have a height or low concentration of the ammonia that's being consumed is going to remain consistent. Well, to figure out the rate based on the graph, so we need to draw a slope of the line at the beginning and the tangent of the line at the end. We would find that those triangles are exactly the same. So if we were to graph the rate over time relationships, we'd find it's simply going to be a straight line. It stays the same. Let me introduce you about the reaction half-life time, which is the time required for the concentration of a reactant to decrease to half of its initial value. The equation varies from order to order, where AT is the current concentration and A0 is the initial concentration, and K is the reaction constant and T is time first. In order to find the half-life, we need to isolate T on its own, then replace T to T half and AT minus A0 equal A over 2.
Thank you for the zero order for this great information. Now we will go to the first order. Hi, I'm the first order reaction, which is a chemical reaction in which the rate of reaction is linearly proportional to the concentration of the reacting substance, and raised to power 1.
So we will take this example of the breakdown of hydrogen peroxide. Looking to the data, we realize that where we have a varying concentration, what we will find there's a direct relationship. As we double the concentration, we will double the rate. So if we compensation on the rate law, we will have the rate equal to the rate reaction constant times the concentration of the reactants.
Now if we were to calculate the slope for the first order reaction, there are 2 ways. First is the linear form, second is the exponential form. The slope for all of them will be minus the rate constant K. Now if we were to graph the rate over time for peroxide, in the exponential form will be a straight line, but it's going to be descending over time. Also in the linear form will be descending, since the slope is minus. And we will calculate the natural log of the concentration to draw the graph over time. In order to solve the half-life of first-order reactions, we recall that the rate law of a first-order reaction. Then to find the half-life we need to isolate T and substitute A with A initial over tau. We end up with equation looking like this. Notice that the half-life time for first-order reaction is independent of the initial concentration.